Hello children. Me and 3 of my friends are planning to do a maths project. For this we need to borrow books from our society library. Our society library allows us 3 books per person. So how many books will we get in all? Very tiring to add the number of books. So maybe I should use multiplication. And how do I do that? I'll use these red counters. I'm placing 3 counters in the first row. These are the books that one of my friend will get. 3 counters in the next row. These are the books which second friend of mine will get. 3 counters in the third row. These are the books which third friend will get. And 3 counters in this row, the books which I will get from the library. So how many books do I get from the library in all? Let us see. It is 3 plus 3 plus 3 plus 3 is equal to 12. So what do I have here? I have here 1, 2, 3, 4 rows with 3 counters in each row. So I have 4 into 3 is equal to 12. Let me show you something else. Now supposing I arrange 4 counters in one row, 4 counters in second row, and again 4 counters in third row. So what do I have this time? I have 4 plus 4 plus 4. And can you add this for me? What do we get? We get 12. So what has happened this time? I have 1, 2, 3. 3 rows with 4 counters in each row. So 3 into 4 is equal to 12. So what is this? 4 into 3 is equal to 12. 3 into 4 is equal to 10. So this is commutative law of multiplication. That is, if we multiply in any order, the product remains the same. We have done this multiplication using repeated addition. I can also multiply using skip counting. Let me show you how. So we are ready with square grid with 1 to 100 written on it. I am going to use these red counters and some green counters to show you skip counting of 4. I will place these red counters here, and at every 4th counter I will place a green counter. So again I place the red counters and the 4th counter is going to be green counter. So now again a green counter. I can go on like this endlessly till 100. But I want to show you something. So what have I got under each green counter? 4, 8, 12. So if I am skip counting, I have 4, 8, 12, so on. So what have I got? When it is 1 times 4, it is 4. And when it is 2 times 4, it is 8. And when it is 1, 2 and 3 times 4, it is 12. And what will be 4 times 4? Let us see. What do we get? Yes, we have 16. And like this you can create your own grid and continue the skip counting. I want to show you something else too. Again let us start. Now this time I am going to use green counters and red counters again. So what am I going to do? I am going to place green counters at every 3rd counter. I am going to place the red counter. So again 1, 2 and the 3rd counter is red. Again 1, 2 and the 3rd counter is red. 1, 2, 3rd counter is red. 1, 2 and the 3rd counter will be red. Again I can go on like this. So what have I done this time? I have created skip counting of 3. And how am I going to check? I am going to just move out all the red counters for you to see. So what do I have? I have 3, then 6, then 9, then 12, so on. So what is that? That is 3 taken one time is 3, 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. Do you see we again got the same result? 3 4 times was 12, 4 3 times is also 12. So by skip counting also we are able to show our commutative law. Interesting, isn't it? Don't you do this skip counting when you are moving on the pavement? So next time when you are doing this, create your own skip count table. That's all for today.